Good morning. Now we will discuss about structural model under structural equation modeling. Structural model under structural equation modeling. Let me see the content today. We will start with conceptual model, followed by assumptions, followed by model estimation, model adequacy test, and one case study will be shown to you. If you recall my last lecture, where I said that the structural equation modeling has two parts, one is measurement part, another one is structural part. Structural equation modeling entails the both measurement as well as structural. What I say that measurement and path or confirmatory factor analysis and path analysis, collectively called structural equation modeling. But in last class what I said that you divide it into two parts, one is structural part, another one is measurement part. Measurement part come first, you measure the latent constructs and then use the correlation or covariance between those latent constructs as input to the path analysis of the structural part. So, in measurement part or the confirmatory factor analysis, I have shown the total structure from identification to parameter estimation to model adequacy test and a case study. Same manner, in the almost similar manner we will be discussing today that what is the structural model there, what do we mean by model identification, and how to estimate the parameters, what are the model adequacy tests, and how to apply the same to a case study. In addition, if time permits, I will tell you the total structure. That means, need not necessarily be true that you have to divide always the structural equation model into two separate models and estimate them separately. There is no hard and bound rule, such rules are there. What is there that you can go for one time estimation considering both your measurement and structural model together. But many times what will happen, because of so many parameters to be estimated, so many variables are involved, then what ultimately will happen, the numerical estimation, that it become very cumbersome and many offending estimates will ultimately result into. And when you relate to the real life situation or interpreting the parameters to explain the real life situation, you found out it is very difficult, in the sense it is not matching the concept. Okay. So, rescue is that you separate them into two parts and then do, and if you are saying no, I want to do all together and that will be my better one, because simultaneously measurement and structural part are estimated, that is also good, and then your matrix will be a little bigger and the parameters will be large. So, it is always possible. Okay. So, let us start with a conceptual model of structural model, that is what is given here. If you go back to my first lecture on structural equation modeling, you will find out that I have given this diagram there, and you see this oval shape, that color pick portion, where actually two sets of latent constructs are linked. In that sense, that there is one set known as Xi's, another set known as it is basically eta. So, Xi1, Xi2 and Xi3 and eta 1 and eta 2, there are two sets of latent constructs. Okay. In structural equation modeling, this Xi part, that Xi1, Xi2, Xi, these are all latent exogenous. variables, and eta is termed as latent endogenous variable. Okay. So, we will be now describing in this manner that that there are m latent exogenous variables and n latent endogenous variables. So, if I go back to this slide, that there are 2 endogenous latent variable and 3 exogenous latent variable. So, that means n equal to 2 and m equal to 3. Okay. Now, see the structure again, that these 3 latent exogenous variables, they are affecting 2 latent endogenous variables, and their relationships, it is obviously this is hypothesis relationship, and this relationship you have found through literature review or your own experience. What we are saying, that xi 1 is a variable which is affecting eta 1, not eta 2. Xi 2 is another very exogenous latent variable which is affecting both eta 1 and eta 2, and xi 3 is another latent exogenous variable which is affecting eta 2 only. Now, if we consider from eta 1 point of view, eta 1 is affected by xi 1 and xi 2, and eta 2 is affected by xi 2, xi 3 as well as eta 1. Okay. And their linear relationships are depicted by gamma. So, any relationship between eta and xi is depicted by gamma. So, gamma 1 1, gamma 1 2, gamma 2 3. So, like this, gamma 1 1 means that eta 1 is affected by xi 1, that is why gamma 1 1, 1 is affected by xi 2, that is 1 2. Similarly, it is eta 2 2 2 2 2 and 2 3, that sensitivity. In addition, the relationship between, or the I can say the regression estimate between eta 2 on eta 1, or other way around, basically that effect of eta 1 on eta 2 is beta 2 1. So, if I consider the relationship here, then we can write like this, that gamma is something which denote the relationship like this, that xi is affecting eta through gamma. Okay. Now, if and beta is something where some eta is affecting another eta, that is beta. Okay. So, 2 sets of linear relationship here, gamma which basically exogenous latent variables affect on endogenous latent variable, and beta that one of the endogenous or some endogenous latent variables also affecting endogenous latent variable again, that is your beta. Okay. Now, in addition, if you see the totality of this particular picture, here I think you will find out so see that left hand side, that the latent exogenous constructs are manifested by x variables, and latent endogenous constructs are manifested by y variable. So, in last class you have seen the factor analysis part. There what we have done, we have taken all these xi's and etas as they are the factors, confirmatory factors, and all that x as and y's we have taken as x variables, and we have done a confirmatory factor analysis considering all those latent variables irrespective of whether they are exogenous or endogenous latent variables. We have taken them simultaneously, that they are latent variables without designating which are endogenous and which are exogenous, and then then using confirmatory factor analysis, what you have found out? You have found out the correlation matrix for those latent constructs or latent factors or latent variables. Okay. And now, in your path analysis, we are bringing into account another what is something which is that there are latent exogenous and latent endogenous. So, if I consider only this portion within this shaded figure, then this is path analysis irrespective of this lambda y1 all those things. If I ignore this structure like this gamma and beta in between, and I treat everything as latent and manifest variables the way we have done in confirmatory factor analysis, that will be the measurement model. So, measurement model output is correlation between these latent variables. Now, subsequently when I am using this path analysis, I am saying that there are two sets, one is exogenous latent, another is endogenous latent. The relationship between exogenous latent to endogenous latent is termed in terms of gamma, and within this endogenous to endogenous in terms of beta. Okay. Now, in this lecture, this today's lecture, now what I am saying, I will be discussing more on this path analysis, and later on if time permits I will tell you the totality what way it will be done. Okay. So, now let us see the equations. When you write the path equations, you please keep in mind that your structure of writing equation will be like this. It will help you to come to the matrix form, and then it will be easier for you also to understand how many parameters related to beta, how many parameters related to gamma, how many covariance parameters also you have to estimate it. You see, eta 1 is not affected by any other endogenous latent construct, they are affected by only exogenous latent construct xi 1 and xi 2, and this is the equation. Similarly, for eta 2 this is the equation, and if you write down this in matrix form, you are getting this equation. So, now this is an example. Now, general equation will be like this. General equation will be like this, that eta, how many eta is there? We have considered eta will be m cross 1. Okay. This can be affected by other eta, that m cross 1, and then this one beta will be your m cross, it all depend on. Now, we want m cross 1. So, m cross m if you write, okay, plus it will be affected by xi is n cross 1, then there will be gamma. So, gamma will be m cross n plus your error term will be there, which is again m cross n. This is the general equation. Is it matching m cross 1, m cross 1? Yes, it is matching. This is general equation. So, beta m cross m, gamma m cross n, these are the two parameters what you want to, parameters in the sense parameter matrix what you want to estimate. In addition, there will be other estimates like phi, which is expected value of xi transpose. There will be psi, expected value of zeta transpose. So, and so on. If later on we will see that if any other parameters we require to be estimated. Okay. So, now this equation, if as is both side eta is there, so I will change little bit. We can write I minus beta, okay, into eta equal to gamma xi plus zeta. If you multiplied both sides by I minus eta inverse, then it will be I minus beta inverse gamma xi plus I minus beta inverse zeta. Okay. That is the our structural equation. This is what we are saying, the structural equations. We can say this as also path equations. Okay. So, now come to the assumptions, like your confirmatory factor analysis, this path analysis here or structural model here, certain assumptions. First of all, assumptions related to the latent exogenous variable zeta, which is definitely multivariate normal and its mean value is 0 and covariance matrix is phi. Related to zeta, which is again multivariate normal and with 0 mean vector and psi is the covariance matrix. And what we are saying that the latent exogenous variables are uncorrelated with the error terms related to your eta, and as well as that is, this is the same thing that we are writing that this is 0. And another important issue, if you see this equation eta equal to I minus beta inverse, that means this inverse must exist, otherwise this equation will not be, is not a real one. So, I minus beta is non singular, then only this equation exists. Okay. So, these are the assumptions of structural model of structural equation modeling or in structural equation modeling. Okay. So, that means you just see what we have done, then basically we said that these are the zeta and they are the xi, they are uncorrelated. We cannot make correlation between this. Okay. This is a mean subtracted observation in the sense their mean value is 0. And how many xi is there, zeta is there, this zeta we have considered that zeta will be m, zeta we have considered zeta n zeta. So, that is n. So, I think if we write like this, the zeta is multivariate normal like this 0 and phi. Similarly, eta is multivariate normal, how many eta is there, that is m 0 psi. This is basically related to number of xi, this is number of eta. Okay. So, now let us see what is the covariance structure for this problem. If you see ultimately the covariance structure is like this eta xi, and this side also you write eta and xi. How many eta? Eta variable are m, these variables xi variable are n. So, the total is m plus n here. So, here also m, then m plus n. Okay. Now, this is in total we are talking about the matrix sigma, which is m plus n cross m plus n. This matrix we are partitioning this matrix into two parts, 4 parts. One is this, which is related to eta only, we are saying eta transpose. This one eta xi transpose, this is another matrix. This one xi eta transpose and this one xi transpose. So, this eta matrix, this is nothing but the sigma, that is the total matrix, covariance matrix, which is partitioned into 4. Now, what does it signify? What is this? That matrix of eta transpose, this is nothing but expected value of eta transpose. Similarly, that matrix of eta xi transpose, is expected value of eta xi transpose. Similarly, xi eta transpose, it is expected value of xi eta transpose, and last one xi transpose, expected value of xi and xi transpose. Okay, the covariance structure then, essentially the covariance structure will be like this that we have eta equal to I minus beta inverse gamma xi plus I minus beta inverse zeta. That is our equation, structural equation. So, in order to simplify it, I am writing this is d gamma xi plus d zeta, where d equal to I minus beta inverse. So, you require to find out first expected value of eta transpose. You can write this is expected value of d gamma xi plus d zeta into d gamma xi plus d zeta transpose. So, this multiplication you do, you will be getting something like this. So, d gamma zeta. Now, transpose of this, it will be just reverse xi transpose, gamma transpose, d transpose plus d gamma xi, this one zeta transpose, d transpose. So, this into this plus this into this we have written. Similarly, I can write d zeta xi transpose, gamma transpose, d transpose plus this into this d zeta, zeta transpose, d transpose. So, you see d and gamma, they are constant. So, you can write this d gamma expected value of xi transpose, gamma transpose, d transpose plus d gamma expected value of xi zeta transpose, d transpose plus d expected value of zeta xi transpose, gamma transpose, d transpose plus d expected value of zeta zeta transpose, d transpose. So, d gamma, this one is nothing but phi, expected value of the latent construct, latent exogenous construct is phi, gamma transpose, d transpose plus this will be 0 because latent exogenous construct are uncorrelated with the zeta value, the error term of eta. So, this is 0. Similarly, this is 0. So, finally, d. Now, this one zeta transpose expected value is, we say it is psi. Okay. So, then d transpose. So, then totally we can write like this one equal to d gamma phi gamma transpose plus psi d transpose. This is nothing but I minus beta inverse gamma phi gamma transpose plus psi I minus beta inverse transpose. So, that is our first part. Okay. So, if I say that my covariance structure is this, which is m plus n cross m plus n, my first part is, as we have seen earlier, my first part is sigma eta transpose, which is covariance of this, which already we have found out. This is I minus beta inverse then gamma phi gamma transpose plus psi I minus beta inverse transpose. Okay, first part you have written. What is our second part? Second part is that eta xi transpose, which is expected value of eta xi transpose. So, let us see what is the expected value of eta xi transpose. So, we say eta equal to d gamma xi plus d zeta. We want this into this. So, you can write d gamma xi transpose plus d zeta xi transpose. If you take expected value of this, then this is d gamma expected value of this plus d expected value of zeta xi transpose. This is d gamma phi plus this will be 0. So, our second part is d is I minus b inverse phi gamma. So, you write down here I minus b inverse phi gamma. I minus b inverse phi gamma. So, इसको थोड़ा sorry just change it to I minus b this. Okay, this is the case. What is your third portion? Third portion, or I can the third element is xi eta transpose. So, you find out xi eta transpose, which will be xi into xi transpose gamma transpose d transpose plus xi zeta transpose d transpose. This will become 0 ultimately, and if you take expected value of xi and eta transpose, it can be written like this: gamma transpose I minus beta inverse transpose phi. This term will come. So, I will write here the covariance structure here, that this is gamma transpose I minus beta inverse this transpose phi. Then the final one is our this one xi transpose, expected value of xi transpose is phi. This is my covariance matrix. Okay. So, in terms of parameter estimation, you can say this is sigma theta and these many variables are there, that means m cross n into m cross n. This is the case. So, number of parameters, many parameters to be estimated, and we will see later on that how this can be done. Okay. So, let us go to this slide. So, ultimately this is what is the covariance structure, what I have already shown you, that how the derivation of this covariance. So, the structural model in SEM and the covariance structure looks like this in terms of the parameter values. Okay. Now, we want to that ultimately what you require to do, you require to find out the number of parameters to be estimated. Okay. So, I think one is beta, that beta, in case of beta m cross m parameters to be estimated. In case of gamma, that is m cross n, but because of its symmetric nature, gamma is m cross n, absolutely no problem. Your phi will be, actually it is n cross n matrix, but because of symmetric nature it is n plus 1 by 2. Okay. And similarly psi, that m, here number of parameters to be estimated, m into m plus 1 by 2. Okay. So, then total number of parameters to be estimated m into m plus m into n plus m into m plus 1 by 2 plus n into n plus 1 by 2. Okay. So, what is then this is number of parameter to be estimated. Now, what is your available with you? Available with you is this sigma m plus 1 m plus 1. This is the matrix, known matrix. In terms of S it will be known. So, that is why I am saying known matrix. So, then number of your non redundant parameters will be this. That means, because of symmetric matrix. So, ultimately what will happen, if your t value is greater than m plus n into m plus n plus 1 by 2 unidentified. If it is equal to this, so if I say this quantity is my k, then if it is equal to k, this is uniquely identified. So, unidentified, uniquely identified, and if it is greater than k, that is over identified. And we want either of the two, the last one is desirable and more preferable, this is the preferable one. Okay. Now, if this condition satisfied, this is model necessary condition is satisfied, which is known as order condition is satisfied, and similarly you have to satisfy the rank condition. Okay. Now, let us see here, there are two types of model in path analysis. One is recursive path model, another one is non-recursive path model. Now, see this figure. In this figure, you see that the direction of arrowhead is going in one direction, basically xi 1 to this to this, there is no bidirectional arrows. So, that means eta 1, eta 2 is not affecting eta 1, similar type of that. So, when you find out that you start with and you will not come back to that particular point, if you just follow like this, there is no loop is forming basically. So, ultimately this type of model is known as, suppose if I am able to go from here to here, here to here, again here to here, then it is by that means bidirectional or some loop will be formed, that is not. So, in recursive model this will be the structure. I think for recursive model the properties, all those things you can go through path analysis in detail. Now, in recursive model the sufficient condition, necessary condition what I have described here, the number of parameter to be estimated must be less than the number of non-redundant element in the covariance matrix, and the sufficient condition for recursive model beta must be lower triangular. Actually, when you talk about beta matrix m cross m, what we are meant to say, it will be lower triangular, this side will be all will be 0. Okay. And there you have seen one other matrix which is psi matrix. This is nothing but the relation, the covariance between these zeta values, they must be diagonal. Okay. So, we are saying only these values will be there of and this both side that 0 values will be there. If these two conditions satisfied, then sufficient condition is satisfied, or other way I can say rank condition is satisfied, and this model is estimable. Now, you go to non-recursive model, you see in this non-recursive model what is happening here. Suppose I take this path, eta 1 affecting eta 2, eta 2 affecting eta 3 and eta 3 affecting eta 1. See, I start from eta 1, I am going to eta 2, I am going to eta 3, again I am coming back to eta 1. So, a loop is formed and there is because of this bidirectional arrows. But it is not possible in recursive path model. In non-recursive path model, it is in this type of path model, this type of beta must be triangular or phi must be diagonal, this will not be sufficient condition. The sufficient conditions you have to test through rank condition of the partitioning matrix. I think you have seen the partitioning of a matrix what I mentioned, that I minus beta minus gamma, this partitioning matrix, this partition is employed. So, rank condition of this partition matrix is employed. Now, as I told you in earlier class, this measurement model, for rank condition you can follow Wiley in 1973. They have given some clear cut guidelines that how to understand that a matrix is sufficient enough for estimation. Okay. I hope you are getting. Actually, we started with the general structural equation model, then I showed you the path model inside, then what are the that assumptions and covariance structure how to be computed, and finally, what now I have discussed, that very important one in path analysis. There are two types of path analysis. One is your recursive and another one is non-recursive. Okay. So, your sufficient condition will be different for recursive and non-recursive, please keep in mind. Okay. So, once your model is estimable, identified, it is either uniquely or over identified, preferable is it should be over identified. Once this is done, then you are ready for estimation and you have to estimate. Now, what method you will adopt? Actually, in measurement model, I have shown you that we will develop a function, minimization function f theta, which is log of determinant of capital sigma plus stress of sample covariance matrix S into inverse of the population covariance matrix sigma minus log of sample determinant of sample covariance matrix minus p. That was the minimization function we have used. And how this p comes into consideration? Actually, this p comes from stress of S inverse. The second part we found out, when we say that there is a perfect match, then this will be the situation. So, S inverse is nothing but stress of I, as in case of measurement model we have p manifest variable. So, we have I p cross p identity matrix, which all diagonal elements are 1, of diagonals are 0, and then the stress of the sum of the diagonal, that is p. And we adopted the procedure that x is multivariate normal with p 0 and sigma, and the same procedure can be adopted here. You are getting me? Same procedure you can adopt here. Here what will happen ultimately, in my measurement part we have taken sigma equal to p cross p, but here our sigma is m plus 1 cross m plus 1. So, that means in the same manner if you proceed, you will be getting for structural model, you will be getting a fit function which is known as f theta, which can be written like this, where again I am writing this, that the order of this matrix is m cross n into m cross n plus stress of S sigma inverse, again the order of S will be m cross n into m cross n, minus the same thing will come, that is minus what will happen, stress of S inverse. Now, here S is m plus 1 cross m plus n. So, that will be I again. So, I can write, if I write this one as stress of I, then I is a matrix something like this, of diagonal elements are 1, of diagonal 0, which is m cross 1, m plus n cross m plus n. So, stress of this is m plus n. So, again if you write like this will be m plus n. So, your resultant fit function becomes f theta equal to log of sigma plus stress of S sigma inverse minus log of that determinant of S minus m plus n. Okay. Now, now see ideal case, what will happen? In ideal case, when S equal to sigma, what will happen to f theta? You see f theta will be log of determinant of this. So, I can write this is nothing but S, because S equal to sigma, plus trace of S inverse minus log of determinant of S minus m plus n. So, this is log of determinant of S plus this is trace of I, which is nothing but m plus n minus log of determinant of S minus m plus n, this equal to 0. So, when S is perfectly matching with this, then my fit value is the function becomes 0. The same principle we have adopted in earlier case also. Okay, you see log of this plus this plus this. So, this is my fit function. So, for estimation you will use this minimize f theta with this one. And please remember, ultimately there are many methods of estimation like weighted least square, unweighted least squares, two stage least square, maximum likelihood method, all those things, but it is recommended by many people that go for maximum likelihood estimation. And what is maximum likelihood estimation, that I told you long back. I think in the estimation, when I discussed about estimation in statistics, basic statistics as well as multivariate statistics. Okay. So, essentially that means the identification and estimation related to structural model is known to you now, and it is in a mathematical manner we have described basically, but these mathematics are nothing but then the manipulation of matrix algebra. It seems to be big, but it is not that complex. From just understanding point of view, I am not talking from optimization point of view, that f theta you are optimizing, that will definitely you have to go for numerical methods. Okay. Now, whatever we have discussed so far in relations to structural model, let us see with a case study. We will proceed with the same case study, and the source is also given here, and I have in last class I told you, if you are interested, please go through this case and see that how it is useful. Fantastic, the case study, these are the variables, and there are 9 latent variables, and using these 9 latent variables we are now constructing the structural model. And here what we are saying, that there are 2 types of latent constructs or latent factors, one is exogenous, another one is endogenous. You see what we have written, work hazard, social support and demographics, these 3 things are not affected by any other variables in the model. So, they are exogenous here, but if we consider all other factors or the construct, they are affected by one or more of the exogenous or endogenous factors. So, they are endogenous in nature. So, accordingly also whatever the same nomenclature we have used here, that the relationship or the effect of exogenous construct to endogenous construct is determined by gamma. So, all gamma is coming here. So, this is essentially exogenous construct and these are all endogenous construct. Now, each exogenous construct whenever has an effect with the endogenous construct, that is denoted by gamma, and within endogenous construct it is denoted by beta. And ultimate aim of this model was to find out whether we are able to explain the structural relationship of the variables leading to work injury. Not necessarily that here we are interested to know that what are the variables or latent constructs that is affecting work injury. We are interested to know the structure of relationship, means work hazards to safety environment, maybe safety environment to job description, this thing. So, this type of relationship later on I will explain that the direct and indirect effects are there it will be much more clear. Okay. From the relationship point of view, but from structural model point of view, path analysis point of view, I do not find you are facing any problem here. Okay. Are you facing any problem? If you are really facing problem, then you take your own case. This is one example case, and here we are demonstrating all the things. You take your own case and then you develop similar like this. You use software like SPSS, MOS is there, you can use your Literal is there. So, there are other softwares available where this structural model or path model can be analyzed. Okay. Now, let us see next what happened. I have shown this diagram, this is known as path diagram. Now, this path diagram is converted into path equation or structural equation. This particular structure is very much known to you now, because you have started with a diagram and this type of equations, and if you write in matrix form. So, this is the case. Now, see, although we say that beta will be m cross m, because here there are 6 eta. So, beta will be m cross m, that is 6 cross 6 here, but see many of the betas are 0 here, many of the betas are 0, and if it is not 36 parameters to be estimated, essentially it is reduced to 1, 2, 3, 4, 5, 6, 7, 8, 9 beta parameters to be estimated here. Similarly, in the gamma case also 1, 2, 3, 4, 5, 6, 7, 8, 9, and then rest are the covariance matrix between xi and between zeta, that is what you have to estimate it. So, if I see in terms of model estimation, you see what is happening, we are basically we require to estimate 6 beta parameters, 9 gamma parameters, and 6 this parameter, is it 6, 1, 2, 3, 4, 5, 6, no, it is basically 9. Okay. So, this will be 9, 9, 6, and 5 is 6, because there are 3 this one 3 C 2, 3 into 2 by 1, okay, that is 6 will be there, m plus n into n plus 1 by 2, that is 6, that is fantastic. So, 6 is there. So, ultimately this will be 9. So, ultimately you are estimating the 30 parameters, T is number of parameter to be estimated is 30. Now, what is the independent elements, known elements from sigma point of view? It is 9 into 9 plus 1 by 2, that is 45. So, the model is over identified as T, the number of parameter to be estimated is much less than number of non redundant element in the covariance matrix, which is known from sample data. Okay. So, it is not 27, I think, let me check beta 2 1 2, yes, it is not 27, it is 30. Okay. This minimum correction, minor correction you do. So, let us see that the sample and data case here, and I do not want to explain further, because we have explained much on this, okay, in the measurement model. Now, measurement model will have given you this correlation matrix. Again, here we are using correlation matrix, and we are interested to see the pattern, strength and pattern of relationships. Okay. So, fine. Now, this is the input to your software, to the we have used Literal to Literal. So, model results is like this. These values, gamma, beta values is come from the model. Now, the star is given everywhere, where somewhere star is there, somewhere not there, where it is not there, this relationship is not significant, which we are talking here in terms of test of parameters. We have so much of parameters and their estimate values, standard error, then t values. Using t values, you will be able to find out which are the parameters is. Okay. And now, what another issue I want to say here, that these tests are similar to regression parameter test. Okay. I hope that you are getting it. And adequacy test, all the adequate the indices what we have used in measurement model, and I have discussed in detail what are all those things. The same thing is applicable here for the structural model also, and for our case this is the scenario. Our case means for the case study. Okay. And you see that the case study results are convincing in the adequacy point of view, it is convincing. Most of the measures are very much related to almost near to 0.9, and in addition to your this goodness fit, there is squared multiple correlation similar to R square values, how much variability is explained for all the endogenous latent construct, and you find out that for safety environment it is high like this, for say personality it is like, for work injury it is less, but the path is stressed here and with a high degree of relationship, that adequacy, it is good enough. Now, another important issue is in structural model, that direct effect and indirect. What is direct effect and what is indirect effect? For example, let I am saying this is my eta 1 and this one is suppose xi 1 and this is xi 2 and this one is eta 2 and this is eta 3. I want to know, suppose the linkage is like this. I want to know what is the effect of xi 1 on eta 1, then this effect is directly I want to, this is the direct effect. But if I want to know for this, I cannot get direct, I have to go through this path. So, multiply this multiplied by this give me the effect here. So, this is indirect effect. So, okay, so that means every endogenous construct might have a direct effect as well as indirect effect. So, within this context here, if I want to know what is the direct effect on work injury, then you will be getting here only this and this. So, 3 variables, job dissatisfaction, safe behavior and job stress has direct effect, all others has indirect effect. So, now see that result here, work hazard no direct effect, indirect effect, direct effect plus indirect effect is the total effect. So, in that manner we calculated and we found out that job dissatisfaction is the main reason for work injury, followed by your this one safety environment. Safe work behavior is coming in the 4th position. The same thing we have done for safe work behavior. Suppose we want to know what are the factors that are contributing to safe work behavior and what is their rank, then direct indirect effect, and finally, we found that social support is primarily responsible for safe work behavior. The more social support, the better safe behavior. It is not job safety environment or job stress in that sense, but social support safety environment is coming very close together, and for total effect point this is large compared to others. Similarly, for job dissatisfaction, interestingly work hazard is coming into. So, the contrast in the situation. We usually understand that work injury is very much affected by work hazards, true, but it is not direct. So, because if you see work injury, where is the work hazard? Work hazard is coming in 3rd position, but when we are talking about your job dissatisfaction, it is coming in the 1st, and when I talk about work injury versus job dissatisfaction, it is coming into the 1st positions. So, this structural relation is very important for taking decisions, and because these organizational issues are very important, not necessarily the technical issues or engineering issues will always contribute, particularly in a complex situation of work injury. Okay. So, apart from this, I think I want to tell you one more issue here. Suppose I will not go for measurement and structural model separately, I will go for only one model, all measurement and structure simultaneously. Then you will be having equation like this, you will be having equation I minus beta inverse gamma xi plus zeta, this will be your one equation. Then another equation will be your y is lambda y eta plus epsilon, another equation will be x lambda x xi plus delta. So, these 3 equations when you split into 2 parts, first you establish this through measurement model and then this one through structural model. Now, if you want to estimate all those things simultaneously, you are doing same, means taking everything in one go. So, in this case now your that covariance structure will be like this, that what matrix you will be analyzing finally. So, this will be y transpose, this will be that covariance of y x transpose, this will be covariance of x y transpose, and this will be covariance of x x transpose. Earlier here you have seen this one, that we have done like this: covariance of eta eta transpose, covariance of eta xi transpose, covariance of xi eta transpose, covariance of eta eta transpose, that you have calculated. Now, here your case is different. You are getting me? Now, if this is the case, suppose then what you require to do? You require to find out expected value of y transpose. Then this is nothing but you just see x, that eta y lambda y eta plus epsilon and lambda y eta plus epsilon transpose and expected value of this. Okay. So, you see what will happen ultimately, lambda y expected value of eta eta transpose lambda y transpose will come from here. Now, from assumption point of view, eta and epsilon are uncorrelated, epsilon is uncorrelated, plus, so those two expected value will be 0, plus what you will get expected value of epsilon epsilon transpose. So, then essentially it will be this, and you have seen that we have found out this one in measurement model. What is this value? We have found out, I will show you this value. We found out earlier, I think you just see that expected value of this is I minus beta of this is the bigger quantity. So, if I write here, then this part will become like this, I minus beta inverse, then gamma phi gamma transpose plus psi I minus beta inverse transpose this into y transpose, plus what will happen, this epsilon epsilon transpose. You will see that we are talking about this equation. This equation, this is the arrow term, which we can write delta epsilon. This is the covariance between epsilon epsilon. So, essentially your, that means this one, the matrix become not m cross, here it is m plus n cross m plus n, here it is, suppose we have p y variables and q, or p x variable and q y variable, then total variable is p plus q. So, our matrix is p plus q into p plus q, and this one is partitioned into, first one is sigma y transpose, that is p cross p, then this one is sigma y x transpose, this is p into q. So, like this sigma x y transpose, that is p, this is q cross q, this is q cross p, and this one is p cross q, like this. This is x transpose p cross p. Okay. So, that means what you can do, you have to find out this matrix for everyone like this. Okay. So, your big matrix will be there. Now, your then f theta will become again the same manner, log of this plus trace of s epsilon inverse minus log of s minus now p plus q. This is the function you are going to minimize. So, okay, you have one end s, another end sigma theta. Now, minimizing this function, finding out this value, and then your number of parameters to be estimated is definitely much more, because the measurement model parameter and structural model parameter all are coming into consideration, all will be taken into consideration here. Model identification point of view, it will be difficult, because then so many parameters are involved. Anyhow, this is also possible, and many a times we do this. The advantage of doing this in one go, that means the interaction between everything, every variables, and that interaction start, that is controlled. Every parameter estimate is controlled by the effect of the other parameters in a logical manner, and this is not in nutshell what is in true sense. This is the last one, when you combine everything together, estimate everything at a go, and then that is the complete structural equation modeling. Okay. So, structural equation modeling is a big issue. It is not that simple altogether, and again I must show my that gratitude and respect to the persons who have developed these useful things, and for all of you, you have to practice it. You use the software, you find out case where you have expertise, not that arbitrarily hypothetical case will give you any insight. There are many nitty-gritty, and now that structural equation in total what I have described, this is the linear scale, it has non-linear also. So, it lot of advancement had taken place over the years. Okay. And some advanced structural equation modeling, if you find out, please go through. Wonderful. Thank you very much.